So that's all we're going to look at here. We're on page 215. We'll have a lab on Friday. That one I've been kind of talking about. It just, with some short days, we can't get through it. Probably need to get through a little bit of information before we get there as well. So instead of drawing pictures today, we're just going to look at an example of a problem. Okay? And so we're going to look at page 215. And we're looking at number 1. And we're looking at A. So you would go ahead and make sure you write this out. It's 2NO, nitrogen monoxide gas. It's going to react with oxygen gas. When it does, the new product is going to be nitrogen dioxide. They balance it for you. So they're gonna balance it for you. I'm gonna have you do a little bit of balancing when on that sheet I gave you yesterday. Was anybody gone yesterday? Okay. Brittany, those are the problems we did based upon your graph. Did you graph? Yes. Did you graph on Tuesday? So those, if you want to copy those off to the right where it says page 205, those are the questions. Okay, so you can write those down. So, but this is a recipe. This 2 can stand for 2 moles. Okay, or it can stand for 2 liters, depending upon what we're given. All right, if they give us moles, define moles or find volume, then one time we'll use moles, another time we'll use liters. Okay, because depending upon the type of problem that they're asking us to solve for, we're going to use either one of those units. Okay, it says that given the same conditions of the temperature and pressure, what is the volume of O2? All right, so here's O2. And it wants to know the volume of O2. All right? Now, this ratio we have is a 2 to 1 to 2. How many liters do we have of NO? So how many liters do they say we have of NO in the problem? No, we have 2 liters. This is 2 liters to 1 liter to 2 liter ratio, simplest ratio. But how many do we have? 4, right? 4. So we would write 4 liters, okay? And we would write 4 liters of NO. Okay? So if this is 4, then oxygen is going to be what? 2, right? Hayden? Because it's double, right? So if I double this, this doubles. Does that make sense? So this is 2 to 1 or 4 to 2. Now, what you want to do is you want to set these up because a lot of times they're not that simple of a relationship. That's kind of that direct relationship. If this doubles, that doubles. That doubles. Okay? So we're going to put 4 liters of NO, and how you would set it up to solve for it by just converting is your liters of NO will go down here, and your liters of O2 would go up here. And then your numbers in your ratio would go in the spot down here. So that would go 2 liters, okay, to 1 liter, right? So then our answer is going to be 2, right? Does that make sense? 2O2. Okay, 2 liters of O2. Any questions you have on that? Pretty simple. This is the key right here. If you can do this, successfully every single time to put the compounds in the right spots, then you're always going to come up with the answer. You're never going to have a wrong answer. Okay? Liters of NO cancel out. Get your answer. Okay? So, part B, it says, how might chemists use their knowledge of molar volume to monitor progress of a reaction? Okay? So, when they look at a reaction, how could they determine the progress of it? They would just see how much is being made at any point in time and see how far it's went along. So, if I had 4 liters here, and then during the reaction, I have just 2 liters produced, then the reaction is not complete yet. I'd have to make 4 liters of this for the reaction to be complete. So unless I got 4 liters, the reaction's not done yet. Okay. Number 2. This one you guys are gonna help me write out. Okay. They're given a word equation. You guys help me write it out. So it says carbon monoxide gas. You may know what would that formula be? Carbon mono means what? 1. So carbon monoxide is this CO. Carbon dioxide would be CO2. Okay? It's going to react with oxygen gas. How do we write oxygen gas? You guys know?
O2.
O2. Very good. It's diatomic. O2. Alright? It's going to react to make carbon dioxide gas, CO2. You guys go ahead and balance that. See if you guys can balance it. That's one of the skills that you're going to have to show is balancing. See if you can correctly write the numbers in front to where the atoms will be equal. That allows us to get our ratios. You guys, what'd you get? You get it? So, remember, just the way to remember balancing this O2, if I put a number in front of this, I'm just going to get an even number of oxygens. So if I put a 2 in front of CO, and a 2 in front of CO2, it's balanced, right? Okay. So now we got another one that's similar to the last one, 2, 1, 2, 1, 2. In question B, asks us that to convert 50 moles of carbon monoxide. So I got 50 moles of CO. And it wants it to convert to carbon dioxide. So my answer needs to be moles of CO2. So we're going to set it up. You guys set it up and see what you get. Based upon the last example we went through. So go ahead, set that one up, and see what you get. Process to do. So down here I put moles of CO, and up here I put moles of CO2. Notice I don't put numbers in front until I know what I have to cancel. So then that would be 2 to 2, right? So sometimes you don't even have to do this because you can see 2 in front. If their numbers are the same in front, then we're going to end up with the same value as what we started out with, but just of the different compound or element.
So same, if there was no number in front of
Yeah.
CO2, it'd be like 25?
Right, so if I said add 25 of CO, how much CO2 would be produced? 25. It's the same number. So sometimes you don't even have to show this, okay? Because I know for you looking at it, or even if if it's a 2 to 1 ratio,
It's just
you can see it half. So if I was going to oxygen, it'd be 2 to 1. If I had 50, it'd be half that amount, 25. That's that relationship. It's just a ratio. That's all it is. Problem. Why don't you do the next one on your own? And it says what volume would be needed to react with 968 liters of carbon monoxide. So we have 968 liters of carbon monoxide. And what it wants to know is oxygen that's needed to react. Okay, so go ahead and set that one up. So we're going from liters, from CO, and then our final answer needs to be liters of O2. Okay, so again, on that last question, you'd have your 20 would be tripled and 182 would be tripled because it's a 1 to 3 ratio.
Sometimes you guys learn the Chinese are not square.